We're now going to develop and use a common identity. This identity is in the form a squared plus b squared equals c squared, and as such, we actually call it a Pythagorean identity. So we'll actually have three of these, but we're just going to look at one right now. So we're going to start with the equation for the unit circle. Remember that equation was x squared plus y squared equals 1. Since x is the cosine of theta and y is the sine of theta, I can substitute those in. And when I do, that tells me that x squared plus y squared equals 1 would be the same as cosine theta all squared plus sine theta all squared equals 1. This is our first Pythagorean identity. So we learned that cosine theta all squared plus sine theta all squared equals 1. We can actually use this to find some values if I know a little bit of information. So suppose I know sine theta is 0.6 and theta is in quadrant 1. If I want to find the values of cosine theta and tan theta, I can actually use this Pythagorean identity. If I know sine, it's rather easy to get cosine. So I use my Pythagorean identity. I know cos theta squared plus sine theta all squared equals 1. And I know that sine theta is 0.6. So that tells me that cos theta squared plus 0.6 squared is 1. So cos theta all squared plus, and when I square 0.6, I get 0.36 equals 1. Solve now for cos theta squared. So cos theta squared is 0.64. And now when I take the square root, I end up getting that the cosine of theta is either plus or minus 0.8. Remember, when I do this, I can sometimes get a cosine value that's positive, sometimes get a cosine value that's negative. But remember, I'm in quadrant 1. And in quadrant 1, everybody's positive, so therefore the cosine of theta has to be positive 0.8. Now we know tangent is sine over cosine, so we can get that. I know the sine value, I know the cosine value. The sine value is 0.6, the cosine value is 0.8, so the tangent of theta is 0.6 divided by 0.8. And if I divide that out, it comes out to be 0.75 or 3/4. So it's kind of neat how I can use that Pythagorean identity to do a problem like that, isn't it?